All right, we're going to be graphing, so if you want to sketch along with us, that'd be great, or you can do it on your calculator, but then it's harder to see exactly on the tables, and this is more intuitive if you're going to do it by hand first. Later on your tests and quizzes, great, do your calculator, but for now, by hand is nice. So f of x is our first equation, 2 to the x power, so I have my axes, 2 to the x power. I want to make a table, just these three values. If I plug in -1 for my x, what's 2 to the negative first power? 1/2. If I plug in 0, what's 2 to the 0 power? 1. If I plug in 1, what's 2 to the first? 2. All right, I'm going to graph these. I'll change to black for the second graph. So I have -1, 0, and 1. At negative, I should do the same scale. There we go. -1 is at 1/2. 0 is at 1. 1 is at 2, okay? And from our parent function section, we know that there's an asymptote there at x equals 0, or y equals 0, and it goes up like that, okay? Now switching to black. So that was f of x. Now for f inverse of x, which is going to be log base 2 of x, log base 2 of, let's not do -1. Let's do, and we can't do 0. Let's do 1, 4, and we'll do 8 after this, actually. All right, well, and we'll do 1/2. Okay, so if I want to know what y is when I have log base 2 of 1/2. So my x value is 1/2. What is the y value? What's the input? What's the exponent that makes this true? -1. If I had base 2 of 1, 2 to what power makes 1? 0. I should have had a 2 in here. There we go. So if I had base 2 of 2, then this would be a 1 exponent. This will be squared and that'll be cubed. I picked those numbers on purpose. So let's graph it and see what it looks like. At 1/2 of my x, my y is at -1. At 0, it's at 1, or at 1 on my x, it's on 0 on my y. 2, 3, 4, 5, 6, 7, 8. Okay. 2 is at 1. 4 is at 2. 8 is at 3. So we see a curve. Okay. What do you notice about these two curves? Why does this happen? If I drew a dashed line at y equals x, what does that remind you of? Part of it gives it away. This is an inverse. Because the reflections over y equals x, they are inverses of each other. If you have -1, 0, and 1 in your original exponential function, you can put those in your y values and then go backwards and find the ones that's 1/2, 1, and 2. 1/2, 1, and 2 that go with it because they're inverses. They just switch your x's and y's. All right. So try to graph the following here. I'm going to sketch it really fast so that you can just check, but see if you can do the same tables. I'm going to do more of it in my head, just trying to go fast with this because I can't pause the video. So base is 3. I'll do the same thing. G of x will be in purple. So 3 of -1, there we go. 3 of -1 is 1/3, so there's 1/3. 0, 1. Oh, 0, 1's always on here. 1 goes to the 3, and that'll be my curve. It's a little more steep this time, and it gets closer to y equals 0, because it is a smaller value. It'll still approach it. It's still a limit. It won't actually hit 0. And then for the inverse, I know if I can reflect this. So if I know -1 is 1/3, then I know 1/3 is -1. If 0, 1 is this point, then I know, if 0, 1, then I know 1, 0 is a point. And if 1, 3 is, then I know 3, 1 is. So you don't need a table for both, you just need 1 and go through the point, and you're golden. Awesome. And we're done.